Hi! In this video, we'll discuss setting up a participant using the EyeLink 1000 Plus in the desktop mount for high precision tracking in the head stabilized mode. First, we want to make sure our participant is set up as we discussed in the tracker installation videos. It's helpful during camera setup to be able to see the camera image on the display PC. To do that, we can click the Image to Display PC button on the host, or click the Enter key on either keyboard. You can use the left and right arrow keys to switch between the global and zoomed views of the camera image. We'll start with the global view. You can move the camera in the ball and socket mount to the desktop to make sure that the eye you want to track is clearly visible in the camera image and not too far off to the edge. If you're tracking in binocular mode, make sure one eye is on either side of the dotted line. If you're tracking only one eye, make sure the correct eye is selected as the eye tracked in the camera setup screen. If the wrong eye is selected, the quality of the data will be perfectly fine. We just don't want the data file to say that we tracked the left eye when we actually tracked the right. If the image is too blurry, you can do a quick rough focus just by turning the camera lens to clear things up a bit. If you see this red circle, that means that search limits are enabled, and the EyeLink will only search for the eye if it's within this circle. You can simply click on the eye to center the search limit on that eye. If you're tracking in binocular mode, you'll need to click on each eye individually. You should now see crosshairs on the pupil and corneal reflection, indicating that the eye has been acquired. Next, we'll want to make sure that the camera is properly focused. Use the left or right arrow keys to switch to the zoomed view. Then slowly turn the lens. We want to make sure that the corneal reflection is as small as possible. You can see when the image becomes blurry, the corneal reflection grows. There, that looks good. The next step is to set our threshold values for the pupil and corneal reflection. The threshold values help the eye tracker identify the pupil and corneal reflection in the camera image. The pupil and CR thresholds represent values on a grayscale ranging from 0 to 255, where 0 is black and 255 is white. Any parts of the camera image with a lower grayscale value than the pupil threshold, meaning the dark parts of the image, will be colored in dark blue. And any parts of the camera image with a higher grayscale value than the CR threshold will be colored in cyan. These will be the bright parts of the image. To set the thresholds, start by clicking the Auto Threshold button on the host PC, or pressing the A key on either keyboard. Then make fine adjustments if necessary. First, let's check the pupil threshold. We want the pupil to be fully filled in with the dark blue thresholding color, but we want to avoid seeing blue coloring in the periphery that could overlap with the pupil, as this could disrupt tracking. You can use the threshold adjustment buttons on the host PC, or use the up and down arrow keys to adjust the pupil threshold. You can see as I raise the threshold value, more of the image is colored in blue, and as I lower the value, less of the image is colored. There, the pupil is filled in. Now let's check the CR threshold. As with the pupil, we want to make sure the CR itself is fully filled in with the cyan coloring, and that you don't see any additional coloring in the sclera, the white part of the eye. It can be fine to see some on the skin around the eye. We can use the CR threshold adjustment buttons on the host, or the plus and minus keys on the keyboard. With the CR, you can see that as I raise the threshold value, less of the image is colored in cyan, and when I lower the threshold value, more of the image is colored in cyan. There, that looks good. To double check our thresholding, we can have the participant fixate the four corners of the screen and observe the eye window to ensure that the eye is still tracked at all the extremes of the screen. You can check out our troubleshooting video for more information on fixing threshold values. The next step is to calibrate the participant. During calibration, the participant will fixate a series of targets on the display PC monitor. This calibration process maps the participant's eye position on the camera to their gaze position on the screen. We'll be using a 9-point calibration today, but you can specify the number of targets in your experiment script or in the Set Options screen of the host PC. To begin, click the Calibrate button or press C on either keyboard. When you begin calibration, a target will appear on the screen. Instruct the participant to fixate the center of the target and to follow that target as it moves around the screen. You can tell them to keep looking at the center of the target until it has moved to its new location. The black area on the host PC calibration screen represents the display PC monitor, and the D cursor on the screen represents the current position of the eye in the camera image. The eye position right now is uncalibrated, so the cursor won't fall on top of the calibration targets. When the participant is fixating the first target and the gaze cursor is steady, press the space bar or click Accept Fixation to start the calibration. By default, the calibration will automatically proceed through the rest of the targets. During calibration, the host PC will draw a crosshair representing the position of the eye on the camera for each of the calibration targets. We should monitor the host PC during calibration to make sure the pattern of the crosshairs matches the pattern of the calibration targets. With the 9-point calibration, we should see the crosshairs form a 3x3 grid. If a crosshair looks out of position, you can press backspace to step back through previous calibration targets. Once the calibration crosshairs look good, you can perform a validation by pressing the V key. To the participant, validation will appear identical to the calibration procedure, but on the host PC, the participant's gaze cursor will now reflect the measured gaze position on the display PC monitor. When the participant is fixating the first target and the gaze cursor is steady, press the space bar or click Accept Fixation to start the validation. Validation will report the accuracy for each point, as well as the average and maximum error values. Typically, for healthy adult participants with normal vision, we recommend using criteria of a half-degree average error and 1-degree maximum error. If the error values you obtain are higher than your criteria, you may need to make adjustments to the camera setup or participant setup. Once your validation looks good, you can click Accept or press Enter to go back to the camera setup screen. From here, you can click Output Record or press O to proceed with your experiment. You can check out our troubleshooting videos for more information on fixing camera setup issues.